On today's episode of IEEE Pune's podcast Beyond Conversations, our guest is Mr. Mudit Dholakia, an accomplished professional serving as Associate Director at UBS, where he spearheads the data and analytics team supporting the bank's data analytics platform. With a robust arsenal of skills and certifications in Microsoft Power Platform, Python, Tableau, Azure, Alteryx, GCP, and Oracle Cloud, Mudit designs, develops, and deploys data-driven applications and dashboards. These solutions not only elevate customer experience but also optimize business processes, driving tangible value for the organization. In this interview, we delved into the keys to success in data science and analytics, uncovering what makes a proficient analyst, the challenges they face, and the ever-evolving demands of the industry. From navigating complex projects to mastering technical skills, we explored the dynamic landscape of data-driven decision-making. This conversation provided valuable insights for aspiring engineers eager to embark on a rewarding career path in the burgeoning field. So when did you decide to pursue a career in data engineering and analytics particularly? Since a lot of students are interested in the fintech space, can you tell us what data engineering and analytics looks like in the fintech space?
See, as I've said, my first experience with the data was when I was doing my master's. It was a general computer engineering master's. I wasn't doing any sort of major specialization. However, I was interested in a buzzword called data analytics and at the same time, data analytics through AI, I would say. So sort of a machine learning and all things were quite new. I won't say extremely new, but yeah, those were the buzzwords in 2014-15 times. So people were so keen to learn all these technologies, and they were very keen to show their interest in basically these technologies. So the first interaction which I had with the data was when I was doing my MTech training. It was a lab where I saw a data product which was in gigabytes. And it was not only one product, it was just the data of a satellite capturing an image of 10 meters by 10 meters Earth, I would say, an Earth image of 10 meter by 10 meter resolution. Definitely on a satellite space, it is a lot of data. We always see that, at our end, we just click on a map and it just loads so beautifully. But behind that, there is a lot of engineering work that happens. So probably that was one of the first interaction of mine at that point in time, where I was literally interested. Generally, we always have a perception that data is nothing but some sort of structured mode, or probably when the data word comes into our mind, it is always an Excel sheet or something that has number of rows, number of columns, and or else something which I can take in pen drive or probably in a hard disk and put it into somebody else's hard disk. So that's basically the layman understanding of data. But it was the first time when I actually realized that this is what the actual data is. And that's a real world data. So you cannot just play the way you want to play with it. There are certain standards which you will have to follow. There are certain specific methods which you will have to learn to apply, how you can actually extract the important information outside of that huge data. And those, some GBs of files were not like 10 or 100. There were thousands of such files which were collected by the receiver and we used to process it and show some sort of analytics through Python, and did some supervised learning to ensure that it shows us the actual classification point on the earth.
Mm-hmm.
So that was, as I said, the first interaction. However, during my professional journey, if I tell you, starting from the first year of my career, I have been introduced to multiple data platforms, namely Tableau, ClickView, ClickSense, Power BI, and there were some SAP analytics tools and Adobe analytics tools, and people were so interested to learn concept called ETL, which is a core at data engineering. So that is, you extract the data, you transform it, and then you load it to the desired table so that you can do reporting on top of it. So that is basically the motivation that I perceived from my initial days, that it is so cool. Like, you can drag and drop certain columns, you can do filtering quickly. At the same time, you need not to write any sort of long SQL. Because what I learned in my college, well, actually, it was also important, but again, the thing that I learned was to write complex SQL queries, subroutines or procedures, or stored procedures specifically in P and SQL. So that I had an understanding around the same thing, that any data, if we want to query or if we want to have an information which is important out of it, we need to basically fire a SQL query to get the essence of it. Let's say there is a huge employee table and we want to extract certain information out of it. People will just write SQL query and they will just get the data and they will report on top of it. However, these data engineering tools and concept actually saw me that there is a different way. You need not to be an expert of a SQL at all. You just need to be a data engineer. You just should know that what exactly is the data. And there will be tools which will be at your hand, at your desk, to process, to transform that data and bring that data in a format, no matter wherever you are, whatever situation you are in, and whatever analysis that you want to carry out. So that's basically the thing which I feel that motivated me enough to pursue the field of data engineering, especially.
I'd like to ask a follow-up question to that. So you've spoken about how when you started working in these big organizations, you found out about a lot of tools that were used to, manage data and visualize data. So what's the challenge of being a data engineer today if it's not writing complex SQL queries?
The challenge for a data engineer today would be the volume of the data. That is the first thing. Every day, every second, the data is growing. So the first challenge for any of the data engineer is to how basically narrow down the data. It's a data size. It's not always true that whatever is there in any of the space, be it a fintech space, be it any other healthcare sector or whichever it is, the data keeps on growing. So you should not be, making copies of it and then doing your analysis on top of it. If you actually do that, you may see some sort of performance issues on your analysis as well, and there would be strategic delays due to that. So in my view, the first challenge is data volume. The second thing is, once you decide that this is what the volume that you want to bring in, the challenge comes next is the transformation, or in a better word, I would say the cleaning of a data, because you never know that who has designed the procedure of the data to be collected.
Right.
So not always you do work with the application owners. So it could be the case that there is a lot of junk involved into that. So you need to ensure, I mean, there are basic concepts in database that we always say that all the rows are unique. Because of primary key, we do have the foreign key level constraints and normalizations, and all those things are applied. Even though we have applied all those things, there are a lot of noise present in the data. So the second challenge that each of the data engineer has is the cleaning, the cleanliness of the data to maintain. And once that step is done, I think you are at the halfway through.
Okay.
The third challenge, which is one of the most important challenge, because we are at the halfway, we know that this is the report-ready data that we have got. We have transformed the data, we have applied cleaning, we have done joins, normalizations, and a lot of things we have already done. But now it is important that you aggregate your data, because let's say if I tell you that I need a total of number of transactions which are present in X table for certain date, or I would say I want total number of transactions that are happening on monthly basis. Now, if I write a subroutine, or if I even use a tool which performs a query all the time on the whole table. Now imagine a banking database where you have millions and billions of records, and the data is growing. Now, for a first instance, you would say that, okay, that routine has performed so well. You might have certain caching mechanisms as well. But with the growing and changing data specifically, you do not have a materialized view of it. That is very important, to create a materialized view which has all sort of aggregations, be it any of the math function that you take. It could be a view on top of your actual table. It would be an aggregation like average or sum or minimum, maximum, whatsoever analysis that you want to do. So any quantifiable measure that you can take on your data, that would be one of the last step that you would do before you can actually make your data completely ready for your reporting. And that will impact the speed of analytics. So when you say you have done all the data cleaning and sort of transformation work, now you're ready to report or show the analysis on top of that, that will be the actual speed of your report. And there are certain technologies that you can use into that. Some people say that even after aggregation, I have, let's say, some million of row. So do I need to perform it every time? But again, you do have massively parallel processing mechanisms which are available in data engineering nowadays. You have cloud, which is altogether a very powerful tool which can transform your data. So these are basically the three challenges which I feel are the most difficult situations which puts data engineer into a nutshell and into a box, basically, which data engineer will have to understand and come out of it.
That's very interesting to hear. So you've been working in very prestigious organizations, a lot of multinational banks. How have all your experiences shaped you as a professional? How have they shaped your professional growth and your skill development?
Yeah. So, I mean, starting with a managed service organization, it was pretty much clear that at any point in time, if you want to accelerate into your career,
Mhm.
the only thing which will take you to so-called success, because there are a lot of definitions of success. So if you actually want to sail through this storm, I would say,
Mhm.
you will have to ensure that you have enough skills. Now, I give you an example. When I was recruited for my first company,
Mhm.
I I joined that company, and there is a concept called bench. So what
Yeah.
happens is, if you don't have, enough skill set, they
Mhm.
might delay certain projects for you because they already have certain candidates lined up, and then they select you to ensure that you have a project allocated. So for those sort of things, when I was on actually bench,
Mhm.
it was really frustrating for me that why I am on bench. I mean, when you are actually doing uh, great stuff, you have learned so much, you have been trained on certain things, and still you are not having the project in your hand.
That's true.
And then I chose that it's not going to be one skill
Mhm.
that will make you successful in your career. It's not something that only one, Harry Potter's magic wand can help you to sail through. You need multiple hats to succeed in the professional journey. And that's when I started learning Tableau for the first time,
Mhm.
because the technology which I got trained on was completely different as to what the projects were demanding, I would say. So that was the first thing when I actually looked back and
Mhm.
realized that this would help me. Now, talking about the different BFSI organizations that I've worked for, most of them are multinational banks, in fact, all of them. So, one thing which I've realized is that you have to be process oriented. You cannot say that, okay, you know this, let's implement this and just finish the work. There is a process, there is a standard that has been set by the bank, which you will have to follow.
Mhm.
So let's say if call you that Aditi, I want to implement this thing, and Aditi knows that thing already, and he says that, hey, Mudit,
Mhm.
I know already this thing. I have a code for it, and here is something that we can use. Yes, it's allowed, and the culture is very open in such organization that you
Mhm.
can speak up. You can definitely raise your voice, stating that you know something
Yeah.
which would save a lot of time instead
Mhm.
of spending a lot of time on it. There is this thing which is already available. So, but again, at the same time, I would say that we will have to first test it, because even though we all are experts in our field, we never know what gets changed at what point in time. So any technology could change at any point in time,
That's true.
which might break the functionality of what you have implemented. So you need to think, and predictably, you will have to forecast the future for yourself or for your project, that,
Mhm.
okay, this is what I need, and this could be the situation. The sort of a disaster recovery you will have to do.
Right.
We all have seen the COVID, and we have
Yeah.
seen that, none of us were so prepared for it.
Mhm.
So that has uh, made us learn a lot, that, okay, if we don't plan it well, the things could go in a different direction as to where they should go. So
That's
that
true.
was, yeah. In professional world, that is that is basically the first thing that you always want to do. Um, if you want to succeed, what you should be doing is um, plan well. Is the first thing that I would think of when somebody says that describe your professional journey. You should be planning well in order to uh, make sure that the thing is going in right way. The second thing is to put yourself in somebody else's shoes. It's not always true that, yeah, it's not always true that whatever you are thinking is right. So at times, I know that this code is perfect and it will work. So let's put it into our functional queue, and I have decided and followed the process, and now we are ready to go, and that functionality will be available soon. But it could be the thing that there would be a better code or better stuff that is already available at a lower cost or at lower delay,
Right.
as to what Aditi has designed. So it could be certain milliseconds of benefit for me, but if it is, then I would probably have to look into that as well. So I cannot deny the fact that I would be stubborn on to certain things. Instead, I would be open to listen to a lot of other stuffs as well and look at the situations. And that would probably make us through to this journey. So, in a nutshell, I would say during my professional journey, starting from the first year till reaching to this point, my main motive to succeed was to learn with open heart and to listen carefully to what others have to say first, rather than just, putting my point in front and winning the battle, which is going nowhere.
That's true. Moving on to the next question. Can you tell us about your key responsibilities and achievements in your current role? What does the day in a life of a data engineering and analytics professional look like?
Exactly. So, well, day looks like the similar, like normal human being. I wake up in the morning and go to office as well. So it's the same day. But yeah, looking from the professional journey, um, you can say it's sort of a roller coaster ride, but it's very interesting at point in time. So the work, from the achievement point of view, I would not brag around the achievements, especially. But again, if you tell me that one of the finest achievement that we would want to highlight during my professional journey is while I was at MTech, I did my research in artificial intelligence application, and I had been awarded with a prestigious President Award, which is Vikram Sarabhai Junior Scientist National Award in 2015. And yeah, then I had contributed to a lot of projects, and I keep on learning from those. And the biggest learning that I have is you are allowed to make mistakes. So the achievement which I always take as a key takeaway from any of the major achievement is that you are allowed to fail. So as long as you are allowed to fail and you are not repeating that mistake again, probably you are the person who will sail through to any of the situation that is put in front of you. So that was about the achievements. In my current work, what I generally do is I carry out a lot of analysis on multiple tooling, specifically on the server estates that we have within our platforms. And we generally do analyze a lot of data, and we work with the business stakeholders to cater to their requirements. And we generally select the best technology to deliver the best-in-class analytics to those folks. So that's our job as a data engineer, to ensure that the data is available, at the same time governed, and at the same time it is secured. Because in the banking world, if I talk specifically, the security of data is very important. So I can't say that all the data is accessible to everyone. So we will have to ensure that who is the actual owner of the data. Even though being an owner of the data, I'm not allowed to share the data the way I want.
Right.
It will be the way the compliance say. So within the boundaries of compliance, I can share certain data, I cannot share certain data as well. And at the same time, we will have to make sure that the analytical platform that we choose is the optimal for the bank, at the same time for stakeholders. So choosing the data analytics platform, because we do have multiple platforms available. So you have to do your research on daily basis that for this particular requirement, what would be that specific tool that is going to satisfy all the business cases. So at point in time, let's say I have this A tool that is having this functionality and costing this much or costing that much, and it can solve this problem. But it could be possible that you cannot solve the problem for other data engineering solutions. So to have only one data engineering way is not beneficial all the time. So you have to be adaptive in terms of what you deliver and what you choose as a data and analytics platform owner. And that will basically carry out the outlook of your bank going forward, because nowadays all the organizations have become data driven.
That's true.
So nothing happens without the data. So that is the first appetite of any organization, is to have the data in proper place, in a proper manner, and at the same time analyze properly. So being a data engineer, we use those tools. We allow multiple people to utilize those things, because we are not the ones who are only data engineers in the organization. There are a lot of other people who are doing a lot of stuff on their data, and basically it's our job to ensure that whatever is the business use case, accordingly we will satisfy the need of the feeding of the data.
Right. That's exciting to hear, especially as a student, because for us, it's quite easy to access probably AI technologies today, generative AI, what's going on behind there. But data engineering is more of a field that works on larger projects. So as a student, what we have access to are pretty much, smaller data sets. And because we're making very prototype kind of projects, which we can feed only a certain specific limited amount of data to. And then that's why data engineering is a field that seems kind of alien to students. And I'm sure that your answer will give a lot of context to what that field actually means.
Absolutely. You have rightly said, Aditi. During our college, we don't deal with a lot of data. And that is where the internships and trainings come into the picture during our probably third year or fourth year, when we actually go into industry and see what exactly is happening. But again, having said that, the colleges are not wrong. Their curriculum is not something which is lagging behind in terms of data. It's just that the theoretical and the basic conceptual knowledge is being given by them, but the real world exposure will always be through industry. So it's a mix of both. You need the basic concepts, at the same time you need to be aware of the industrial practices as well around any field, be it a data engineering or I would say a normal engineering as well. You can say you can take any of the branch of engineering. Unless and until you actually know the industrial practice, you won't be able to correlate those basic concepts which our professors used to write on the blackboard. And we always feel that, where exactly I'm going to apply it. But these are the concepts that we actually apply on top of all these industrial practices.
That's true. You've been working on a myriad of data engineering technologies and platforms. Can you tell us about some of the most important platforms that are used in the industry, and what are some challenges that you have faced during your experiences with these platforms?
Well, it's really an interesting question, because being a data engineer, till date, it is really hard to find one platform which is actually complete. Because there are, varieties of platforms which offers n number of functionalities.
Yes.
Now, out of that n, certain functionalities are not available in one technology. It could be available in another technology. So bridging those gaps is one of the most interesting things as an answer to this question, which I'm going to give you. So, there are a lot of tools, but again, if we divide the data paradigm into three aspects, let's say data engineering, which will prepare the data.
Right.
And then there is a data analytics, which will do all the analysis stuff for you.
Right.
Now, it could be possible that you leverage certain AI tools the way you are saying, right? That you just upload an Excel sheet onto ChatGPT and say that, give me this formula. And it just gives you those results on top of that. That's one example of analyzing the data through AI. Now, the third paradigm which I'm talking about in terms of data is the data science. So you have prepared the data, you have analyzed the data. Now you are actually grabbing the insights from that for the foreseeable future.
Right.
So you are actually doing predictive analysis, you are doing supervised learning, you are doing the clustering, classification, KNN, lots of activities on top of your analysis and bringing out what could be the possible aspect of the data that is important for you to understand out of the whole analysis that you have created. So in all these three verticals, we have different tools. Now, if you take into the data engineering, basically, there are a lot of players like Microsoft, there is an Informatica, Amazon is there, Google is there, SAP is there again. So they do have their technologies which will connect to probably hundreds of data sources, because generally what happens is you don't have one specific technology which you use to store your data. Some people store their data into Oracle database, some people may store it into the Hadoop, some may store it into Microsoft SQL Server, some may store it in cloud, or probably imagine that I am a video editor. Now my videos are also nothing but the data.
Right. Yeah.
I want to have an analysis on top of that. So for people who are misunderstanding the conceptual definition of data, it's not always the rows and columns. That's
Yeah.
a myth,
Mhm.
right? So it could be any data, and the data engineering tools like these can actually connect to these sort of data as well and churn out the meaningful transformations out of it. So it's up to different technologies and different business cases where you choose the right tool for your business requirement. So nowadays, Informatica, Azure Data Factory, at the same time, Airflow in the cloud. If you have heard the
Yep.
name of
Apache Airflow.
Apache Airflow, these are some of the most important data engineering tools, I would say. And it has got a lot of, supportive mechanisms like the concept called Kafka is
Yeah.
there. In a cloud world, they call it as PubSub, where you can do a lot of stuff of data engineering with that.
Yeah.
Then there are certain cloud technologies which support you with the deployments of these pipelines. You can take GitHub, GitLab, you have the SVN repositories, you do have the Git Bash to do all these things. You have
Yeah.
stash repositories. So in the world of data engineering, it is not limited to a tool. It is basically the vast expanse of the functionality that you want to achieve during your analysis.
Yeah.
So that's important to understand that what exactly you need. And based on that, you select your technology. Now, I don't find that particular thing as extremely challenging because nowadays we do have a lot of resources available.
That's true.
So earlier it used to be like, if I want to, I had a case during my professional journey that I wanted to use Tableau as a reporting tool, which can connect to one of the important cybersecurity tool, but that tool was not leveraging the data through Microsoft SQL Server.
Okay.
So at that point in time, Tableau, though being a data analytics tool, works as the data engineering tool to an extent where you actually write a web data connector, and through that web data connector, you can inherently connect that Tableau directly to make the calls to that particular data through REST API. And so does the Power BI as well.
Right.
So it is important to understand which tool would be serving the purpose, which will satisfy your business requirement. Now coming to the second paradigm, that is data analytics. Now, data analytics is nothing but quite a correlational term to business intelligence,
Right.
and which is one of the favorite field for me during my career journey, because I, though being a data engineer, my whole professional journey has been into business intelligence world. But I've interacted with a lot of platforms which actually drives the business analysis. These tools actually impact the business analysis. Certain analysts, be it any of the analysts like business analysts, financial analysts, different sectorial analysts are there, risk analysts are there. So analysis could be of anything. So in analytics world, we do have a ranking nowadays, which is very famous, which is given by Gartner. It is one of the important insight partner at a global level. So let's say if you are searching for a good college, right?
Yeah.
So you actually look for the NIRF ratings.
Yeah.
That what is the NIRF rating of that particular college? How is the placement and all such things?
That's true.
Beyond the cost, right? So such rating is also available in the data analytics world as well. though it is driven by industries, a lot of experts have views on that. But the Gartner's report is very important. So if you, and I would like to tell every viewer who is watching our video that at any point in time, if you are facing challenges to select a particular data analysis tool, I would recommend you use Gartner's Magic Quadrant.
Yes.
So there are 4 quadrants. One is the leader, one is visionary, one is the niche players, and another is new entrants.
Okay.
So that particular chart will give you the actual picture, and whichever tools are in Magic Quadrant, I consider to be one of the top-notch tools in the industry. So right now, since last, I would say, 3 to 4 years, Power BI has been the most key tools in terms of analysis. Now, there are a lot of factors like cost. It's a very cost-friendly tool. People definitely want to save a lot of money so that at the same time they can spend on some other stuffs or can reserve those money for certain challenging scenarios. So Power BI is one of the very flexible tool. It provides a lot of functionalities, a lot of flexibility to analysts, and that whatever engineered data that you have bought from the previous tools like Informatica or Cloud PubSub, Apache Airflow, or it could be the Azure Functions or the Azure Data Factory. Whatever materialistic table that you have created, these can connect to any of these data source and can bring insights to you. The second tool which comes, which is like in the visualization world, people sometimes are so married to it, I would say, is Tableau. Yeah, I use the word specifically married because in recent times, there is a battle going on between Tableau and Power BI.
Power BI, yeah.
Right. So people talk a lot around Tableau versus Power BI, Tableau versus Power BI.
Yeah.
And every organization is facing a lot of challenges because earlier Tableau was basically one of the widely adopted BI tools. Then Microsoft came up with the Power Platform, which is a suite of applications. There are a lot of applications like Power BI, Power Platform, Power Automate, Power Apps, I would say. Power Pages is one of the famous technologies which is included in Power Platform. And over the period of time, these technologies had emerged as the integrated platforms. So let's say I am creating a report into Power BI and I want to share it into the teams. So I can actually click on share and I can actually share that into the teams. And people can actually, without going into the browser, they can see it into the teams. So that is one of the most powerful functionalities which is available in Power BI. Now, on the contrary, the same functionality is available in Tableau, but because Tableau is in that Salesforce periphery right now, they are allowing the share options to their own internal chat platform, that is Slack.
Right.
So you can share any dashboard, any insights to Slack. So people always say that which is better, Teams is better, or Slack is better, or Tableau is better, or Power BI is better. So a lot of battles are going around that. So we'll not go deep into that. But this is one of the challenges that has emerged over the period of time, which actually tells you that how difficult it is to come down to one particular technology and say that, okay, this is the technology. And that is what I actually mentioned during our initial conversation, that it is not easy to adopt to any single platform always. Because it varies based on a lot of different aspects as well. There are certain other technologies like SAP Business Objects, ClickView, then there is Denodo, Domo. So Then AWS has also got their sort of a BI tool. So there are a lot of tools which you can use and build your reports on top of that. There is an Oracle BI as well, which is used with the Oracle ecosystem. So it's all about the ecosystem from where you are actually bringing your data.
Data, yeah.
But coming to the magic quadrant of Gartner, these tools basically allow you to connect to almost hundreds and hundreds of data sources, be it at anywhere in the world, be it on cloud, be it on Oracle, be it on SQL Server, be it a PDF file as well. I've seen like people can do analysis from PDF file, and one of the most interesting features in Power BI that is available nowadays is you can actually connect to your email exchange.
Okay.
Yes. So sometimes what happens is when you, I'm not sure whether you have come through this particular use case or not, but a lot of companies do provide their customer care email IDs for raising tickets.
Yeah.
Now they don't have so they don't have the backend database always to maintain those ticketing stuff. So they collaborate through email. And still, if you want to analyze that, your Power BI can help around that as well. That's one of the important features that people are using that solves their purpose of analysis. And quickly coming to the third paradigm, that is data science. Now, it's a very vast topic. Once you have analyzed your data, you can probably export it into any of the format that you need. You can do n number of regression on that, and after applying regression, you do some sort of modeling, then you do the model validation, then you have training and testing data set. You can do a lot of methods like classification, supervised methods, clustering, and having all those things in place, you can actually build a particular AI model which is fit for your requirements. And then you probably will not have to do all these three things together. It will just be your data, and you just feed it into your AI model, and it will give you all the insights. And there are a lot of models. NLP is one of the best example of it. Then LLM, which is large language model. The best ever thing that we are blessed with is the Chat GPT is one of the example of it. So, I mean, it's a very, I would say, vast topic to discuss. If we completely discuss it, I think probably years and years would go and the chat won't end. So, in a nutshell, the 3D, which I've just spoken, the data analysis, data engineering, and data science are some of the most important aspects when you deal with the data. And the main challenge is the adoption of the right technology in this world.
Right.
Yeah.
That's true. That's a lot to digest, even in the terms of information that we spoke about right now.
Yeah.
I have a very interesting question on data migration coming up.